So hello all, in today's video we are going to see insertion function from the concept doubly linked list. We are going to see insertion of three types: at starting or at beginning, in middle, or in the desired position, and at end. So these are the three ways of inserting element into your doubly linked list. It's very similar concept to your singly linked list. However, we know that the node representation in doubly linked list is different, so the connections or the linking is also going to be different. Let's try to understand this topic in detail. I have already written down the pointers for you. So we start with the very first thing, that we are trying to insert a node at the starting position. There's a diagrammatic representation of the same. Let's try to understand this. So suppose this is your old node. Okay, this is your old node and I am trying to insert a node. I'm trying to insert a node at the beginning. So very first is I'll create a new node. Are you getting this? I'll create a new node. This new node should be placed at the starting of your doubly linked list. Now, when you are trying to insert it at the starting, that means your first node is your head node. Now the new inserted node should be your head. Let's try to see how this execution is done programmatically. So over here, as you can see, let's go step by step. Very first line that you see is, memory allocation. We have already seen this concept in our previous video, doubly linked list, basics of doubly linked list. So your node creation, memory allocation for your node. PTR is the name of your node, and this is the node that you have created. PTR is the new node that you have created. This will help you to build this structure of a node. For doubly linked list, our node looks something like this: data, previous, next. So this structure, this memory is allocated using this line, and the name of this node is going to be PTR. Okay. After that, now I need to do the linking part. So the first line says is PTR to previous equal to null. PTR to previous is equal to null. Let's see. PTR to previous. PTR is the name of the node. To previous, that is this part, that has to be null, because when I'm trying to insert the node at the starting, we know it that the starting node will always be, the previous part will be null. It should look something like this, right? This is your starting node. So now this is the new node that is created and it has to be placed in the starting. So its previous, PTR previous, should be null. So that is what I have mentioned over here. Next thing I say is PTR to next. Now what should be in the next part? Next part should hold this node's link. The next part should hold the next node's link. So what is my next node? My next node is head. Okay, in this case, this is head. Can you see this? This is the old link. I have mentioned it. So this is head for now, and this is new node. I have created this new node. In the previous part, I have put null, and in the next part, I am putting head. Okay, so PTR to next is head. So then this connection is established. After that, head to previous. Now this is the head. I have still not changed the head. Head is still over here. Head to previous. What should be in the previous part of the head? Earlier it was null because it was the starting node. Now what am I supposed to do? I am supposed to put PTR. So head to previous. Head to previous should be your PTR. So then this link is connected. Are you getting it? PTR to next is head. This is the link. Head to previous. This is the link. After that, I need, now the connections are done. Now I need to shift my head. So what will be head? So this new node will be head. So head equal to PTR. So whichever is your PTR, in this case, this will become your head. So can you see this connection? Head. Very simple. You just need to know the linking part. This is insertion of node at the beginning. Okay. Let's try to see the second one. We are trying to insert the node at the middle position, or at the position where the user is expecting it to be there. So this is the diagram. We already have our first node. Our first node is head. Okay, we have two consecutive nodes after that, and this is the new node that I want to insert. Okay, so this new node is named as PTR. Let's try to understand it by code, what is happening over here. So earlier when my linked list was there, this is how the linked list was. This node was not there. Okay, it was only 1, 2, 3. And the link was what? this node connected to this node connected to this. So this was the old link. Can you see that? I've mentioned, right? This was the old link. Now when a new node comes up, this linking should go off. This node should be connected to this and this should be connected to this, and vice versa. That is the connection I want. Let's go step by step. Very first, we need to do the allocation of memory. So I'm going to create a node similar over here. I have not written the line, but you have to create the node. The node's name is PTR. Okay, so a new node is created whose name is PTR. After that, now let's do the linking part. What should happen now? PTR to next. This is PTR, PTR to next. What should be in the next part? This node, right? And where is this node? This node is here. Now we know the concept that when I want to insert a node, I need to travel through my linked list and come to a position. So I'll have a for loop which will help me to come till the position that I want to, and that will be a temp that will go on incrementing. Once it comes here, what I'll do? Temp to next. What is in the temps next? This address. So this address should be here. And where is this address? Here. So what do I say? PTR to next. PTR to next should have what? Temp to next, because temp to next has what? This. After that, PTR to previous. PTR to previous. This should have what? Temps next. So here PTR to previous is temp. So PTR is temp. Clear? After that, temp to next is equal to PTR. What should be in the temps next? Now these two positions are filled, right? PTR to next, I've got the value. PTR to previous, I've got the value. Here I have temp and here I have this value. So this connection is done. This new node is connected. Now here the previous part is pending. This is linked, the alternate part is pending. Now here, temp to next. Temp to next. What should be in temp to next? Temp to next is PTR. So temp to next will be PTR. Okay, so this linking is also done. Okay, this is done, this is done, this is done. What is left? Here, the upper part. Temp to next to previous. Temp to next to next. Temp to next is this. What is there in next? This node, right? And what is the what is its previous? This node's previous is this. So temp to next to previous is PTR. Temp to next to previous. Now when you say previous, temp to next, this. What is temp to next? This node. And to its previous is this node. Clear? So here you get your connection. So that is what happens here. After that, the next thing that we have is at the end. Now I want to insert the node at the end. So this is your linked list. This is your starting head. You have nodes connected and this is your last node. What should happen now? The last node is going to have its next as null, right? Last node has null. So what am I supposed to do? I'm supposed to remove this null. Whatever is my new node, that should be linked. Okay, so let's see how it is done. Over here, temp is going to help me to come to the position. It will come to last position where temp to next is null. So after coming here, my temp is pointing here. Alright, I'll put a for loop. This for loop is already studied in your singly linked list. Go through that video to understand how we traversing. I will come till the last node. After that, what do? Temp to next. This is your next. What should come over here? PTR. PTR is what? My new node. I've used the same name, right, for all the nodes, new nodes created. So PTR is a new node. So temp to next is equal to PTR. Similarly, PTR to previous. PTR to previous. What should be there? Temp. So this is connected. Clear? And PTR to next. PTR's next should be null because it is the last node. There is no linking node. Clear? So that is what we do in our insertion operations in singly linked list. 3 types, at start, at middle, at end. Go through the execution diagrammatically. Once you understand this execution, that's when you can, understand the programmatic execution also. The same thing is written into your program. Similarly, we have deletion at start, deletion at the desired position, and deletion at end. And very similar to this, in our next video, we'll cover that topic. Okay.